All right, welcome to it. This is class assignment 7. This will be our first squared around. A truly square base up to a 4-inch round and with an elevation of 6.5 inches. So I kind of need those 3 dimensions to work on something like this. And so I've provided you with that. And so we can take those to AutoCAD and lay that out and just start drawing. So I'm going to take, I think I've got those instructions in AutoCAD already. So let me head over there. Yeah, and I've already actually started drawing this. So what you'll see me in this video do is this is a drawing that I've already done. And so I can just toggle on and off the steps that I do, and maybe I'll just talk through what I drew and where I'm taking that. So I'll see how that goes for this video. This particular drawing I'll probably put up on our on Blackboard as well. It kind of has a step-by-step description that I've got on my drawing screen, and I'm just going to talk through that. And so if I put this drawing up on Blackboard, it would have that. You'd be able to read over that, but it's going to be a lot of what I just talk through as I do this. So the initial thing is I need to know is that information, and I'm just going to draw that in. The biggest thing, I guess that's the difference here too, is that we're going to be using a top view, maybe considered as a plan view, and then the front view or the elevation view. So we need 2 views of our orthographic projection to be able to get the information to develop these squared arounds. And so I don't think we have to do any right or left side view stuff, just top view and front view. And so the initial thing that I'm drawing over here, so I need this information. I got a round of 4 inches, square of 8 inches, and an elevation of 6.5 inches. I'm just going to use those as is. I'm not going to do any metal calculations. I'm not going to do any deductions for flanges that might be necessary or any additions for flanges. So these are just going to be just kind of blank. If you refer to my last video, this is just going to be like blanked off on the top and bottom and not really go anywhere, but it is a transitional piece. And so let's get to this drawing. So I ended up starting to draw with a top view here. So this here I've been able to, I might just throw my layers up over here on the left so I can kind of toggle them on and off. But this is a 8x8 square with a 4-inch circle in the middle. And I've just got some center lines kind of drawn in there as reference lines. That's my initial step. I think I kind of dimension that out. Get in the habit of checking your dimensions, making sure that you snap to the right diameters. Always double check that. Whether you leave the dimensions there or not is up to you. Sometimes I'll put those on a layer where I toggle them on and off if they get in my way. So that shows that I've got a 4, 8, and then I've taken and divided our circle by our standard 12 divisions. So the step that I just turned on, got all these new lines that appeared, different colors here. So what I've done is standard 12 divisions, and then I snapped so then if I'm looking at my center line here, my yellow center lines, that put node points so that I could kind of divide this in quarters. And so for all those node points, the ones that kind of share on the center lines, I took those to corresponding corners. So I snapped these lines in and snapped in, so for every center line they go to the corner, and then the ones in between go to the corners. So the interesting thing about this is where it's a kind of a concentric, that means the round and the square share the same center. It's kind of an equal taper, is another word I use for this, but each quadrant of this is symmetrical. So where the sides are the same length, what I've got is all of these magenta colored lines are the same length in this view. So I've used that color to kind of signify to myself that those are the same lengths. Whether I'm pulling from this 12 o'clock position, what I'm looking at here, down to this corner, it's the same distance from this corner back up to this position at 9 o'clock, and vice versa. So I use that as a color-coded system, and I change that up when I go to something that's not symmetrical, or anyway, as that changes, maybe I would refer to a different color to keep that straight. But each one of these lines goes to one of my 12 node points. I think then maybe I project those down. So after I draw those in, I've actually, now I'm ready to project all this down to a front view. So that kind of is a point where I've got some information to take to establish a new view. So what I've done is just project the outside dimensions of the square down here. And this is just kind of an arbitrary length down. I've just developed it down to give myself some space in between my views. So no particular dimension there. But I've projected these down and drawn in my baseline and projected my center lines down. And once I have my baseline drawn at that, and I'm projecting the round, I do the projection lines for the round down to this area. All I'm left to do is like put in that 6.5 inch dimension here. So once I kind of establish I'm far enough away from that picture, I can work off the base there and draw my actual 6.5 inch center line there. That gives me a place to put in these two lines that are both 2 inches here on each side of center. It looks like I've drawn those off of center. That's why my piece, as I highlight here, looks like I've just drawn a 2 inch line out from center and a 2 inch line out from center. You could do that with a circle. There's all kinds of ways, whatever works to get these dimensions in there. I've done the same thing. I've kind of worked off center lines here. It looks like I've got a 4 inch line here and a 4 inch line here. I could join those up and make them a polyline. Looks like I've just left them separate here. Once I put in that elevation and these widths, that kind of allows me to like put in the sides of the squared around. So yeah, one thing I want to point out is the outside perimeter of this squared around. What the actual line of sight that I'm seeing there on either the left or the right side in the front view of that actually correspond with kind of the distance from up here, this point over here where my cursor is, and up to that point there. Like that point is actually picking up what the outside edge of the squared round looks like in the front view. The magenta colored lines, these blue colored lines, they're kind of following away from me in this view, so I don't quite pick them up as the actual outside edge. So kind of interesting what I pick up is almost from the center, this center line towards me in the front view is what I'm actually seeing. So all right, now that I've actually drawn that in, I've kind of used all the dimensions that were given, and so I'm left here to now take my my element lines here. I always consider these orientation lines on the other patterns that we draw on. I call them element lines, elements. I'm going to take those down to the front view and draw them in. Now that since I have them in the top view, I can project those down to the front view. So that's what I've done here. I've just taken and at every point, which was a node point, I project those lines down to the top part of the front view. And that allows me to essentially draw in the remaining lines here. So I kept these green on the outside edges, and that just kind of shows me the outside perimeter of my part. You know, that would almost be considered, I guess, a magenta colored line too, a little bit. I could pick up that magenta colored line that would kind of be in line of sight with that, but I just kept it green on the outside. The other ones I did kind of make the same colors with where the light blue length of lines, which are all, these are all the same lengths here. That one is the same length as that one actually. Where they hit the points on the circle from the corner are the same distance. And yeah, and then I'm picking up the magenta colored lines in the front view that represent these lines here. So one thing I've done to keep myself straight is I think I number this maybe in my next step. Yeah, this is my just kind of a standard numbering system that I showed you guys how to use early on when we were drawing. If it helps keep you straight, this is totally fine. You'll notice maybe my numbering system is different because the numbering system I use is totally arbitrary. I could start on any one of these points and name it 1 through 12. It's just that I would want to keep that when I change views. So if I started here in this view, is kind of the 6 o'clock is 1, 2, 3, and go in a counterclockwise fashion here to 12. I've kind of established a number for every node point. The other thing to notice here is I've actually named my outside corners just letters. And those are arbitrary too. Like I could have started, and I could have named lettered these outside points of the square any configuration of letters. I just chose to start A over here on the left. A, B, C, D are the main points on my square. And then I picked up an additional point that I'm going to use for development. It's E, and it's just on center of the pattern. And it's kind of the one that's just a little bit different than the others. So it's just E. I mean, if I had continued this, maybe I would name some of these other center line points, other letters. The thing is, I don't really need to do that. Like, I'm going to develop some of the stuff starting at E. And because this is a symmetrical pattern, what I do, the development work that I do, say from on this side that represents B to C with E in the middle, all the work that I do to kind of draw this pattern that would be over here, where I'm kind of highlighting, it's going to be the same work that I would do in this, in the upper quadrant of this, and over here on the left side of the pattern. All the sides where they taper from squared around are symmetrical. So really, once I kind of do one pattern here, I'm able to just duplicate that, however I'm going to decide to break up my pattern, which is what the end of the last video was kind of talking about, like where I'm going to put my weld seams, where I want to terminate my patterns. It's totally up to me. So anyway, as I've numbered these, I've just kept that number system as we go down to the front view. So, and I've kept that letter system as we go down to the front view. So one thing I want to point out here is, let's pick that up and let's look at it down in the front view here. So really, before I even head down there, like when this goes to front view, point number 1 and number 7 actually line up with each other in the front view. Like 2 and 6 will line up together in the front view when I turn that circle in the front view. 3 and 5, 4 will kind of be independent. 10 will be independent here. 11 and 9 will line up. 12 and 8 will line up. And when I go to the square section here, B, E, and C will kind of line up in the front view. And over here, A and D will line up. So when I come over here to my front view, what I'm showing you is this. So what we've got here is I've just numbered those same points just for clarity. If it helps you to do this, that's great. Yep, there's point 4, 3 and 5 line up, 2 and 6, 1 and 7, 12 and 8, 11 and 9 and 10. And my points down here below, when I'm looking at this view, this point could either represent A or D. A is the one closest to me in the view. D's, down the away from me. And B is the point closest to me. C is the furthest over 8 inches away, and E is kind of in the middle of those two. So B, E, and C is kind of how I've determined that. So that covers the two views that I need. Now with those drawn like that, I now am ready to interpret all that information and actually make a pattern out of it. It's just a matter of using the top view, plan view, and the elevation front view to talk to each other and to pick up information off each one to develop a pattern. So each one has some key dimensions that I need to communicate to each other. So the first step here is this. I've just now established. What I have done is I've just made this just over to the side. It can go anywhere on the drawing screen. I just need. I'm going to set up a right angle and use Pythagorean Theorem by snapping and copying lines to come up with like true lengths. Because the biggest thing that I'm trying to do is, like in my front view, if I think of this magenta colored line, I can't really take that and use that actual dimension. It is falling away from me in this view. So it adds length to it when it falls away from me. So I see that falling away when I look at the top view here. Like clearly it drops away from the line AB, which is kind of this bottom edge of the square that's towards me in the front view, A to B. If I think of point B and this first magenta colored line, it falls away from me before it falls into point 1. So I can't really tell that from here. I would think, oh, this is just like up towards me, like close to me, but it's not. It has a depth as it falls away, and that makes it a non-true length. So I can't just directly use this information to make a pattern, nor can I use just this information to make a pattern. It has 6.5 inches worth of depth to it that I can't, that I do show that these two lines connect to each other, but they don't actually tell me a true length. So I have to use some kind of a system to figure out what that is. using the information here and here. So what I do, I am kind of locked into that elevation. Like when this part finishes, it does need to end up being 6.5 inches tall. That's critical. So that's the first line. I copy this over. So all I did is grab, copy this elevation line. I think I even grabbed my word elevation. Yep, and I just snapped it over here out of the way. So that was my first step. Just snap my elevation line over here. And then I take and just draw a line. You know, I actually grab a line, pick that point, and just draw it to the right. And it's just an arbitrary length. Like I've drawn it like super long, actually longer than I even need. It's ridiculously long. But what the point is, this length, the length of this line is totally arbitrary. I just need some distance out here, and I probably only need about half that distance or something. I'm just looking to make a 90-degree angle here so that I have a right triangle so I can use Pythagorean Theorem. So now that I've established that, and I'm going to use the actual, like that's a 6.5 inch long line here, 6.5 inches of elevation. So now I'm just going to kind of work around this pattern systematically and get the true lengths that I need to draw a pattern. And if I kind of think of this, if all these lines that are color-coded are kind of the same length, like all the magenta-colored lines are the same length, the blue-colored lines are the same length, really, all I'm really looking for is like the blue-colored true lengths. You know, even though there's like 1, 2, 3, 4, 5, 6, 7, 8 of those lines, they're all the same length. So once I get like my blue-colored length, true length, then I need the magenta-colored true length. So that's also 1, 2, 3, 4, 5, 6, 7, 8 lines, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 lines there. Once I get those, you know, once I figure out one of those true lengths, I've got like 8 other lines for my pattern. And then the only other one I have is this a place to start my pattern, which is I'm actually going to try to figure out also what E to line 4 is. So it's just because I named this point E, where the center line is. It's just going to give me like a way to break up this pattern halfway in between any of these sides, whether it's B to C or A to B. You know, that point E is kind of sits on any of these halfway marks. So I'm actually going to interpret what that length is. So from E to 4 is kind of an independent line, but I'm going to use that. So, and I'll show you how that looks. First thing is, let's find out which one I started with. It was probably E to 4, so I'm going to snap on the next. Yes, exactly what it was. So I snap on my next step, and what I pick up is I drew a circle here using E as the center, and I pulled the radius of that over to 0.4. So what I ended up just picking up was kind of what the spacing is from E to 4. Even though I know it has 6.5 inches of depth that I can't quite see, I still want to pick up that it goes from E to 0.4 in the top view. That's a critical dimension for me. So I just want to find a way to take that dimension and relate it to the 6.5 inches. So what I do is I copy this, actually like grab copy, select this circle from point E, and I actually come down here and I snap it, and I actually labeled this point B because it is actually point B, E, and C. Like those line up in the front view, and that's kind of where I'm taking that information down here to something that relates to the front view, which is the elevation, 6.5 inches, and I just snapped it on here, and now I pick up that this, and what I'm really looking for is this information, you know, just the radius of that circle out to this point on this line. So that tells me that in a 6.5 elevation, my point actually goes from E to 4 this far out, and now I can take this point up to the top of the 6.5 inches, and I end up with the true length of what E to 4 really looks like. Whether I'm looking at it in the front view, which is kind of like right here, E to 4 would kind of almost represent that green line here, but that's, anyway, which almost is probably going to be the true length if I tell you that, but let's just keep going here anyway. So it's just a way for me to like check that, and that's what I probably do on the next step here. I'm going to toggle this on. That's exactly what I did. I just need to finish that. I need to finish that right triangle here. So I snap a line here from the point of my 6.5 inch line to, and I've even labeled this as point E there now. So that just tells me that that is my true length line. And it's funny that I kind of named that E. I think that was for me to keep it straight, that Yeah. I'm trying to think how that won't confuse you, but that's what I was going after, was this length of line here. It references the top view information from E to 4, and then I pull it up to the top, and then I've got this other circle that is actually now the radius is the true length of that line. And what I'm going to do here, just for interesting here, is I'm going to I'm just going to throw a measurement on here. And I just kind of want to show you something here. So this ended up being the true length of what line E to 4 would be. And one reason, that's actually 6.80007, okay. Because that's E to 4. If I think of this point, I didn't name it number 4, but I can kind of consider it that it's 0.4. It's actually just based off the elevation here on one of these. Even though I'm kind of I copied this and took it over, it's the same as if I actually had that from E to 4 here. It's kind of the same as if I named this some other letter to 1. Those distances are the same. The pattern is the same from whatever this point is, it's unnamed, to 1 as it would be from E to 4. So even though I stole the elevation line, and you would think maybe that it lines up with 0.1 and 7 more, I'm just in my mind, I'm already interpreting that, that can represent E to 4. It could represent some other arbitrary point over here that isn't named, to 10. Those are all the same distances. So it really wouldn't matter which one I'm talking, but I am kind of considering this like the top of my elevation pattern, which really, just given the line, is what point it really represents that it lines up to. So that's why I guess I don't give this a hard name, because when I grab the next set of lines, it would kind of change the numbering system to where this top peak point of this Pythagorean Theorem triangle that I've got over here is going to end up representing almost all the numbers just based on what line that I'm trying to interpret the true length of. So I guess I don't give it a hard name there. So, and then I drew this other circle, kind of a tight dotted circle that has this radius, 6.87. or 6.80007. So what I wanted to do is actually, while I'm dimensioning, is just, I kind of want to pull the outside dimension of this, because the interesting thing is this is actually point E to 4 in actual view here. And if I actually pull this on, you will see that that is the same dimension, which is kind of this funny thing to where when I look at the front view, and you'd be like, well, why didn't we just pull that dimension and use it? Well, we could have. If I would have understood that that is picking up a true length right on the point from E to 4, which is kind of halfway in that pattern, the overall profile of the front view does kind of show me a spot on the pattern where there is a true length. But I'm also showing you that I can totally get the same information by taking it from the top view, E to 4, dropping it on this line down here, and I'm going to escape out of this, and then pulling a new line that's based off the actual overall finished elevation. And so that just shows you the amount, what I just did, pulling from my top view down to here, and then using the elevation, it ended up being the same as right here. So I thought that was cool just to see that. I can't do the same thing with the blue lines, because they definitely do not, that blue line does not hit 0.4 to where I'm picking up it's just for only a split second when that thing goes round in the front view at that 0.4 do I actually see that and catch that dimension. So it doesn't hold true for this thing here. So let's go down. Let's develop the next set of lines.